you have a cosmic address right now. It's more specific than any street number or ZIP code. Most people think space is just empty void with scattered objects. That's completely wrong. Tonight we're discovering how the universe organizes itself like the world's most sophisticated filing system. From your local solar neighborhood to structures bigger than imagination, your real cosmic address will change how you see your place in existence. Before we dive into this cosmic postal system, drop a comment about where you're listening from. If you enjoy these late-night space explorations, consider subscribing. These journeys through the cosmos are meant to be shared. Gravity doesn't just make things fall down. This invisible force sorts the entire universe into neighborhoods. For thousands of years, humans wondered how space organized itself. Stars seemed randomly scattered. Galaxies appeared to float wherever they pleased. Scientists discovered something incredible. Gravity acts like the universe's postal worker. It groups similar things together. It creates clear boundaries. It builds neighborhoods within neighborhoods. Your planet belongs to a solar system. That's like your house being on a specific street. Your solar system belongs to a galaxy. That's like your street being in a particular city. Your galaxy belongs to a cluster. That's like your city being in a certain state. This cosmic addressing system works automatically. No one designed it. Physics created it. Every single object in the universe gets sorted into the right cosmic neighborhood by gravity's invisible hand. Your cosmic address works backwards from Earth addresses. The further out you zoom, the bigger your neighborhood gets. Start at Earth. Pull back to see our solar system's position within our galaxy. Keep zooming to see our galaxy's spot within its cluster. Continue outward to see our cluster's place within an even larger structure. Each level reveals you're nested inside something vastly bigger. Your stellar neighborhood contains hundreds of stars. Your galactic region holds billions of these neighborhoods. Your galaxy cluster contains thousands of entire galaxies. Most people live their whole lives thinking they're just on Earth. Actually, you're on Earth inside the solar system, inside the Orion Arm, inside the Milky Way galaxy, inside the local group, inside something called the Virgo Supercluster. That's your complete cosmic address. 7 levels deep. Each level bound together by gravity so strong that even the expansion of the universe can't pull it apart. Space isn't actually empty. Invisible matter creates cosmic property lines everywhere you look. Scientists spent decades mapping where one cosmic neighborhood ends and another begins. They couldn't see the boundaries with regular telescopes. The borders are made of something called dark matter. This invisible material outweighs everything you can see by 5 to 1. It creates cosmic fences that organize the universe. Matter clumps together where dark matter is thick. Empty regions form where dark matter is thin. These boundaries stay put for billions of years. They're more permanent than any human border. They define where galaxies can form and where they cannot. They separate cosmic neighborhoods more effectively than any fence or wall humans ever built. Your cosmic address depends entirely on these invisible boundaries. Without dark matter's organizing power, the universe would be chaos. No neighborhoods, no structure, just scattered debris floating in eternal darkness. The universe grows bigger every second. Most cosmic structures get pulled apart, but your address stays completely stable. Space itself stretches between distant galaxies. This cosmic expansion should tear everything apart. Scientists wondered why some structures survive while others don't. They discovered a cosmic battle. Gravity fights expansion for control. In small neighborhoods, gravity wins. Your solar system won't expand. Your galaxy won't expand. Your galaxy cluster won't expand. Gravity holds these structures together against the universe's outward pull. But at larger scales, expansion wins. Distant galaxy clusters move away from each other faster than gravity can pull them back. This creates a natural cutoff for permanent cosmic addresses. Everything smaller than about 300 million light-years stays gravitationally bound for the long run. Anything bigger gets stretched apart by expansion. This means your cosmic address up to the supercluster level is written in permanent ink. Astronomers spent centuries trying to organize the cosmic zoo. They needed a system to classify every object in the universe. They created the ultimate cosmic filing system. Every star gets a catalog number. Every galaxy receives coordinates. Every cluster has a designation. This system works like social security numbers for space objects. No two objects share the same cosmic ED. Scientists can now mail a letter to any object in the observable universe. They know exactly which galaxy cluster it belongs to. They know which galaxy within that cluster. They know which region within that galaxy. This cataloging system revealed your cosmic address for the first time in human history. Before these surveys, humans didn't know where they lived in the universe. Now every astronomy textbook can print your exact cosmic coordinates. The universe's filing system is finally complete. From the smallest asteroid to the largest supercluster, everything has an address, including you. Why doesn't Earth just fly away into space? A massive invisible hand grips our planet every single second. That hand belongs to the sun. It's called gravity. Without it, Earth would shoot off into the darkness like a runaway baseball. The sun's gravity reaches across 93 million miles to hold Earth in its cosmic grip. This gravitational bond creates your first cosmic address. Think of it like invisible rope connecting Earth to the sun. No matter how fast Earth moves, that rope never breaks. No matter how far Earth travels in its orbit, the sun never lets go. 8 planets orbit our sun this way, each one held by the same invisible force, each one following its own precise path through space. Together, these gravitationally bound objects form your first cosmic neighborhood called the solar system. The sun's gravity doesn't just hold planets. It controls everything within 4 trillion miles. That massive sphere of influence defines your first cosmic address boundary. Earth won the cosmic lottery. We live in the universe's most exclusive neighborhood. Our planet sits in the 3rd lane from the sun, not too close like Mercury and Venus, not too far like Mars and the outer planets. Earth landed in what scientists call the habitable zone. This perfect distance means liquid water can exist on Earth's surface. Closer to the sun and we'd boil like Venus. Further away and we'd freeze like Mars. Earth sits in the cosmic sweet spot where temperatures stay just right for life. Only 3 planets in our entire solar system could possibly support life as we know it. Venus, Earth, and Mars all orbit within the right distance range. But only Earth maintains the perfect conditions. Out of 8 planetary addresses in our solar system, Earth got the only one suitable for living creatures. Your cosmic address begins with this incredible stroke of luck. 3rd planet from the sun in the habitable zone with liquid water oceans. Your solar system is much bigger than you think. It doesn't end at Pluto. Most people imagine the solar system ending somewhere around Neptune or Pluto. That's completely wrong. The sun's influence extends thousands of times further than the most distant planet. Your true cosmic neighborhood stretches nearly halfway to the nearest star. Scientists discovered a vast cloud of icy objects surrounding our entire solar system. This cloud is called the Oort cloud. It contains trillions of frozen chunks left over from the solar system's formation. These objects still orbit the Sun, even though they're incredibly far away. The Oort cloud extends about 1 light-year from the Sun. That's roughly 6 trillion miles. Compare that to Pluto's distance of just 4 billion miles. Your actual solar system neighborhood is 1,500 times bigger than the region containing all the planets. This enormous sphere defines your complete solar system address. From the Sun's surface to the outer edge of the Oort cloud, everything belongs to your local cosmic neighborhood. A cosmic highway runs through the middle of your solar system. It separates 2 completely different neighborhoods. Between Mars and Jupiter lies a belt of rocky debris called the asteroid belt. This region divides the solar system into inner and outer zones. Each zone contains planets with totally different characteristics. The inner zone holds rocky planets like Earth. These worlds are small, solid, and made of metal and stone. Mercury, Venus, Earth, and Mars all belong to this rocky neighborhood. They formed close to the Sun where temperatures were hot enough to melt ice. The outer zone contains giant planets made of gas and ice. Jupiter, Saturn, Uranus, and Neptune are massive compared to Earth. They formed far from the Sun, where temperatures stayed cold enough for water and other materials to freeze into solid chunks. The asteroid belt acts like a cosmic border between these 2 different worlds. Rocky planets on one side, gas giants on the other. This fundamental division defines 2 distinct address zones within your solar system neighborhood. The Sun doesn't just shine light, it blows a constant wind that creates your solar system's mailing address. This solar wind is made of charged particles streaming out from the Sun at incredible speeds. The wind travels much faster than any hurricane on Earth. It flows past all the planets and continues deep into space. Eventually, this wind runs into gas floating between the stars. Where the solar wind meets interstellar space, a boundary forms. Scientists call this boundary the heliopause. It's like a cosmic shoreline where your solar system ends and true outer space begins. The Voyager spacecraft crossed this boundary and sent back data from the other side. They confirmed that your solar system sits inside a bubble carved out by solar wind. Everything inside this bubble belongs to your Sun's domain. Everything outside belongs to interstellar space. This wind-carved boundary gives your solar system a definite edge. Like a fence around your cosmic property, the heliopause marks exactly where your solar address begins and ends. Your complete solar system address extends from the Sun's surface to this invisible wind boundary. Stars don't live alone. When astronomers mapped the space around our Sun, they found we live in a stellar suburb. Within about 30 light-years of our Sun, dozens of other stars call this region home. These stars move through space in roughly the same direction. They share similar ages and compositions. Together, they form what astronomers call the local stellar neighborhood. This cosmic neighborhood works like a loose star cluster. The stars aren't tightly bound together like planets in a solar system. Instead, they drift through space as traveling companions. They all formed from the same giant cloud of gas and dust billions of years ago. Our Sun belongs to this stellar community, whether we realize it or not. The nearest star families include red dwarf stars, white dwarf stars, and stars very similar to our Sun. Each one represents a neighbor in our immediate cosmic vicinity. This local group of stars defines your second level of cosmic address. You don't just live near one star. You live in a neighborhood containing dozens of stellar residents. all moving together through the galaxy. The nearest star to our Sun sits impossibly far away. Even at the speed of light, reaching it would take over 4 years. That closest neighbor is called Proxima Centauri. It's part of a 3-star system known as Alpha Centauri. The distance to this stellar neighbor is about 25 trillion miles. That's roughly 4.2 light-years from our Sun. To understand this distance, imagine shrinking our entire solar system down to the size of a quarter. On that scale, the nearest star would still be over 400 miles away. The space between stars is almost entirely empty. Even in our crowded stellar neighborhood, the stars are separated by vast gulfs of nothingness. This enormous gap between stars defines the boundary of our local neighborhood. Everything closer than about 12 light-years belongs to our immediate stellar vicinity. Everything beyond that distance belongs to more distant neighborhoods. Your cosmic address includes this crucial measurement. You live near the Sun, which sits 4.2 light-years from its nearest stellar neighbor, in a region where stars are spaced trillions of miles apart. Our Sun floats inside a giant bubble carved out by exploding stars. Most people never learn they live inside the aftermath of cosmic violence. This bubble is called the local bubble. It's a region of hot, thin gas stretching about 300 light-years across. The gas temperature reaches over 1 million degrees. Despite the heat, this region contains almost no matter compared to normal space. Massive stars created this bubble when they exploded as supernova millions of years ago. These stellar explosions blasted away most of the gas and dust that once filled this region. The shock waves carved out a hollow cavity in space, and our Sun happens to live inside it. The local bubble shapes everything about our stellar environment. The thin gas affects how light travels between stars. The low density determines which types of stars can form nearby. The hot temperature influences the chemistry of interstellar space around our neighborhood. Your Sun didn't choose to live here. The expanding bubble from ancient supernovae swept our solar system into this cosmic cavity. We're passengers inside a structure created by stellar explosions that happened before our Sun even existed. Our stellar neighborhood contains stars of wildly different ages living side by side. Some stars formed recently while others are nearly as old as the universe itself. The youngest stars in our neighborhood are only a few million years old. They burn bright blue and won't live very long. The oldest stars formed over 10 billion years ago. They glow dim red and will outlive our Sun by trillions of years. Our Sun sits right in the middle of this age range. It's about 4.6 billion years old. That makes it middle-aged compared to the stellar residents around us. Not the youngest star on the block, but far from the oldest either. This age mixing happens because our neighborhood sits in a relatively quiet part of the galaxy. New stars still form occasionally from leftover gas clouds, but mostly we live among stars that drifted here from other places. Each star has its own history and birthplace. Your cosmic address reflects this stellar diversity. You live near a middle-aged yellow star, surrounded by neighbors ranging from cosmic toddlers to ancient survivors, all sharing the same general region of space. Where exactly does our stellar neighborhood sit within the Milky Way galaxy? The answer surprised astronomers for decades. Our local region occupies a spot between the galaxy's major spiral arms. We live in what's called the Orion Arm or local arm. This structure connects two main spiral arms like a bridge between cosmic highways. The major spiral arms contain most of the galaxy's star formation activity. Massive blue stars. Glowing gas clouds and stellar nurseries crowd these galactic main streets. Our neighborhood sits in a quieter spur between these busy regions. This location provides our stellar community with a stable environment. We avoid the chaos and radiation of major spiral arms. We escape the gravitational disruptions that tear apart star clusters in busier regions. We enjoy the galactic equivalent of a peaceful residential street. Your complete cosmic address now includes this galactic geography. You live in the local stellar neighborhood, which sits in the Orion Arm, positioned between the galaxy's major spiral highways, providing a stable home for dozens of neighboring stars. You can't see the center of your own galaxy. Cosmic dust blocks the view like a massive wall of fog. Our sun sits about 26,000 light-years from the galactic center. That places us roughly halfway between the galaxy's heart and its outer edge. Think of the Milky Way like a giant city. We live in the middle-class suburbs, not downtown and not in the countryside. This middle position protects us from the galaxy's dangerous core. The center contains a supermassive black hole weighing 4 million times more than our sun. Intense radiation streams out from this region. Massive stars explode frequently. The gravitational chaos would tear apart any solar systems that venture too close. Our suburban location provides the perfect balance. Close enough to benefit from heavy elements created by previous generations of stars, far enough away to avoid the destruction that plagues the galactic center. This cosmic geography defines your third level of address. You don't just live in the local stellar neighborhood. You live in the galactic middle zone, positioned safely between the chaotic center and the element-poor outer regions. Where exactly does our solar system sit above or below the galaxy's main disk? The answer reveals another layer of your cosmic address. Most of the Milky Way's stars concentrate in a thin disk only about 1,000 light-years thick. Our sun sits slightly above this main disk. We're positioned about 85 light-years north of the galactic midplane. This vertical offset gives us a unique view of our galaxy's structure. We can see both the thick disk below us and the thin disk around us. Stars above and below our position are older and more spread out. Stars at our level are younger and more tightly packed. Our slight elevation above the galactic plane affects everything about our cosmic environment. The density of nearby stars, the amount of cosmic dust in our vicinity, the types of stellar neighbors we encounter as we orbit the galaxy. Your complete galactic address now includes this vertical component. You live 26,000 light-years from the galactic center, positioned 85 light-years above the main stellar disk, in a region where old and young stellar populations mix together. Right now you're racing through space faster than anything humans have ever built. You can't feel it because everything around you moves at the same incredible speed. Our entire solar system orbits the galactic center at 515,000 miles per hour. That's more than 200 times faster than a jet airplane. Despite this tremendous speed, one complete orbit around the galaxy takes 225 million years. This galactic year lasts so long that dinosaurs lived during our solar system's previous orbit. When the sun last completed a full circuit around the galaxy, no grass existed on Earth. No flowers had evolved. Complex life was just beginning to develop. Our orbital motion follows a nearly circular path around the galactic center. Unlike planets that have elliptical orbits, our solar system maintains roughly the same distance from the galaxy's heart. This stable circular orbit keeps us in the galactic habitable zone. Your cosmic motion defines another crucial element of your address. You're not just positioned 26,000 light-years from the galactic center. You're orbiting at that distance at a specific speed, taking 225 million years per complete revolution. Our solar system accidentally ends up in the galactic equivalent of a quiet side street. We live between the galaxy's major highways. The Milky Way's main spiral arms contain most of the galaxy's star formation activity. These cosmic highways teem with massive blue stars, glowing gas clouds, and stellar nurseries. The Perseus arm and Sagittarius arm represent the galaxy's busiest neighborhoods. We occupy a smaller structure called the Orion arm. This minor spiral feature sits between the two major arms like a connecting road. Fewer stars form here. Less radiation floods the environment. Gravity remains more stable over long periods. This quiet location allowed our solar system to survive for 4.6 billion years without major disruption. A position in the main spiral arms would expose us to frequent stellar explosions. The intense radiation would strip away our planet's atmosphere. The gravitational chaos would destabilize planetary orbits. Your galactic neighborhood provides the perfect environment for long-term stability. You live in the Orion arm, positioned safely between the galaxy's major spiral highways, avoiding the cosmic traffic that disrupts solar systems in busier regions. When you look toward the constellation Sagittarius, you're staring directly at the heart of your galaxy. You can't see it because cosmic dust creates an impenetrable wall. The galactic center lies hidden behind vast clouds of interstellar dust. These microscopic particles block visible light like fog blocks headlights. Even the most powerful optical telescopes cannot penetrate this cosmic veil. Astronomers solved this problem by using different types of light. Infrared telescopes can see through dust that blocks visible light. Radio telescopes detect signals that dust cannot stop. X-ray telescopes reveal the violent activity around the galaxy's central black hole. This dust barrier divides our galaxy into visible and invisible halves. We can easily observe the outer regions of the Milky Way. We can study the spiral arms stretching away from the galactic center, but the inner half of our galaxy remains hidden behind interstellar dust clouds. Your cosmic address includes this fundamental limitation. You live on the far side of the galactic center from most of the galaxy's mass, with your view of the inner regions blocked by dust, giving you a permanently one-sided perspective of your own galactic neighborhood. Astronomers discovered our galaxy doesn't live alone. The Milky Way belongs to a cosmic family of over 80 galaxies. This galactic neighborhood is called the local group. It stretches about 10 million light-years across. 3 large galaxies dominate this cosmic territory. Dozens of smaller galaxies orbit around them like planets around stars. The biggest member is the Andromeda galaxy. It contains roughly 1 trillion stars. The Milky Way comes second with about 400 billion stars. The third major member is the Triangulum galaxy with roughly 40 billion stars. All these galaxies are bound together by gravity. They can't escape from each other no matter how fast they move through space. The invisible force that holds your solar system together also holds entire galaxies in cosmic families. This galactic family defines your 4th level of cosmic address. You don't just live in the Milky Way galaxy. You live in the local group of galaxies, gravitationally bound together in space, forming one of the universe's smallest galaxy clusters. The Milky Way isn't the biggest fish in its cosmic pond. Our galaxy plays second fiddle to a larger neighbor. Andromeda galaxy outweighs the Milky Way by at least 2 to 1. It contains more stars, more gas, and more dark matter. Andromeda spans about 220,000 light-years across, while our galaxy measures only 100,000 light-years. This size difference means Andromeda dominates the local group's gravitational politics. It pulls on all the smaller galaxies more strongly than we do. Most of the local group's satellite galaxies actually belong to Andromeda's family rather than ours. Despite being the smaller galaxy, the Milky Way still ranks as a cosmic heavyweight. Among the universe's hundreds of billions of galaxies, both Andromeda and the Milky Way count as giants. Most galaxies are much smaller dwarf systems. Your galactic address reflects this cosmic hierarchy. You live in the second largest galaxy within the local group, dominated by the more massive Andromeda galaxy, but still ranking among the universe's galactic elite. Dozens of smaller galaxies orbit the Milky Way like cosmic pets following their master. These satellite galaxies can't escape our gravitational grip. The most famous satellites are the Large and Small Magellanic Clouds. These dwarf galaxies are visible to the naked eye from the southern hemisphere. They contain millions of stars each, but that's tiny compared to our galaxy's hundreds of billions. These satellite galaxies follow elliptical paths around the Milky Way. Some orbit close enough to exchange gas and stars with our galaxy. Others maintain distant orbits that take billions of years to complete. All of them remain gravitationally enslaved to our galaxy's massive dark matter halo. The Milky Way's satellite system reveals our galaxy's true cosmic weight. The number and behavior of orbiting galaxies tells astronomers how much dark matter our galaxy contains. Without this invisible matter, the satellites would escape into space. Your cosmic neighborhood includes this extensive satellite system. You live in the Milky Way galaxy, which controls dozens of smaller galaxies through gravity, creating a hierarchical family structure within the local group. Two galactic superpowers rule the local group. The Milky Way and Andromeda fight for cosmic control like rival kings. Each galaxy commands its own territory within the local group. Each galaxy controls its own family of satellite galaxies. The space between them remains a contested zone where smaller galaxies get pulled back and forth by competing gravitational forces. This cosmic standoff has lasted for billions of years. Neither galaxy can completely dominate the other because they're too evenly matched. Andromeda may be larger, but the Milky Way holds its ground through sheer gravitational stubbornness. The smaller galaxies in the local group must choose sides in this cosmic conflict. Some orbit Andromeda. Others belong to the Milky Way. A few remain independent, but even they feel the gravitational influence of both galactic giants. Your cosmic address sits at the center of this galactic power struggle. You live in one of two dominant galaxies that control the local group, locked in a gravitational standoff that has shaped the structure of your cosmic neighborhood for billions of years. What happens when an unstoppable force meets an immovable object? In 4.5 billion years, we'll find out. The Milky Way and Andromeda galaxies are racing toward each other at 250,000 miles per hour. Despite the vast distance between them, their mutual gravity ensures they cannot avoid collision. The cosmic expansion of the universe cannot overcome the gravitational attraction between these two galactic giants. When they merge, the collision will create a new galaxy that astronomers have already nicknamed Milkomeda. This cosmic crash will rearrange every star in both galaxies. Our solar system will likely survive, but it will occupy a completely different address in the merged galaxy. The local group's structure will vanish during this galactic merger. The satellite galaxies will be scattered or absorbed. The neat organization that currently defines your cosmic neighborhood will disappear forever. Your cosmic address comes with an expiration date. You currently live in the local group dominated by two separate galaxies. But this gravitational family is destined to collapse into a single massive galaxy, completely rewriting the cosmic postal codes for this region of the universe. Scientists mapping cosmic structures noticed something strange about galaxy motions. Galaxies weren't moving randomly through space. They were all flowing in the same direction. This discovery revealed that the local group belongs to a much larger structure. Our small family of galaxies is just one tiny part of an enormous cosmic city. This giant structure is called the Virgo Supercluster. The Virgo Supercluster contains over 1,300 individual galaxies. It stretches across 110 million light-years of space. At its heart sits the massive Virgo cluster, containing over 2,000 galaxies packed into a relatively small region. All the galaxies in this supercluster are connected by invisible threads of gravity. They can't escape from each other despite the expansion of the universe. The gravitational web holding them together is stronger than the cosmic forces trying to pull them apart. Your cosmic address just expanded dramatically. You don't just live in the local group of galaxies. You live in the Virgo Supercluster, a massive collection of galaxy groups and clusters all bound together by gravity across millions of light years. Every galaxy in your cosmic neighborhood is being dragged toward the same destination. The Virgo cluster acts like a cosmic vacuum cleaner, sucking in everything around it. This central cluster contains 2,000 galaxies packed into a space only 15 million light-years across. The combined mass of all these galaxies creates an irresistible gravitational pull. Everything within 50 million light-years gets dragged toward this galactic feeding frenzy. Our local group is falling toward the Virgo cluster at 400 miles per second. This cosmic journey will take billions of years to complete. By the time we arrive, the cluster will have grown even more massive by consuming other galaxy groups along the way. The Virgo cluster's gravity dominates the motion of every galaxy in the supercluster. No galaxy can escape its pull. No galaxy can resist its influence. The cluster's immense mass makes it the gravitational king of our cosmic region. Your galaxy group is currently riding this cosmic conveyor belt toward the Virgo cluster, joining a stream of galaxies all flowing toward the same gravitational destination in the heart of your supercluster. Your supercluster isn't a random blob of galaxies floating in space. Galaxies organize themselves along invisible highways that telescopes cannot detect. These cosmic highways are called filaments. They're made mostly of dark matter, the invisible material that outweighs regular matter 5 to 1. Galaxies form like beads on a string along these dark matter filaments, creating a vast cosmic web. Between the filaments lie enormous empty regions called voids. These cosmic deserts contain almost no galaxies. Some voids stretch for hundreds of millions of light years without a single major galaxy. The contrast between crowded filaments and empty voids creates the universe's largest scale structure. You cannot see this cosmic web directly because dark matter doesn't emit light. Astronomers map it by tracking how galaxies move and where they cluster. The invisible scaffolding reveals itself through the behavior of visible matter. Your supercluster follows this hidden architecture. The Virgo supercluster stretches along multiple dark matter filaments, with galaxies concentrated where these cosmic highways intersect, creating the complex three-dimensional structure of your cosmic neighborhood. Where exactly does the local group sit within the Virgo supercluster? The answer puts us firmly in the cosmic countryside. Our galaxy group occupies a position far from the supercluster's bustling center. We live about 65 million light-years from the dense Virgo cluster core. That places us in the outer regions where galaxy density drops dramatically. This suburban location protects us from the chaos that plagues central regions. Galaxy collisions happen frequently near the Virgo cluster. Gravitational interactions strip gas from galaxies. The intense environment disrupts star formation and tears apart smaller galaxies. Our peaceful outer position allows galaxy groups, like ours, to survive intact. We avoid the gravitational storms that destroy cosmic structures in crowded regions. We maintain stable orbits without interference from neighboring galaxy groups. Your supercluster address reflects this cosmic geography. You live in the local group, positioned in the outer suburbs of the Virgo Supercluster, safe from the gravitational violence that dominates the central regions where thousands of galaxies compete for space. Something invisible controls the fate of every galaxy in your supercluster. Scientists call this cosmic puppet master the Great Attractor. The Great Attractor contains the mass of tens of thousands of galaxies concentrated in a relatively small region. This enormous concentration of matter creates a gravitational field so strong it influences galaxy motions across hundreds of millions of light years. Even our local group feels its pull. This cosmic monster sits partially hidden behind the plane of our own galaxy. Dust from the Milky Way blocks our direct view of the Great Attractor. Astronomers must use special telescopes that can see through dust to study this gravitational powerhouse. The Great Attractor doesn't just influence individual galaxies. It shapes the large-scale structure of the entire supercluster. Galaxy groups flow toward it like water flowing downhill. The cosmic web itself bends around this massive gravitational anchor. Your cosmic destiny is tied to this invisible giant. Every galaxy in the Virgo supercluster, including our local group, follows trajectories determined by the Great Attractor's immense gravitational influence, making it the true ruler of your cosmic neighborhood. Everything astronomers thought they knew about cosmic structure was wrong. Advanced computer analysis revealed that the Virgo supercluster was just a small piece of something much bigger. Scientists developed new techniques to measure how galaxies move through space. Instead of just looking at where galaxies are located, they mapped which direction each galaxy travels. This velocity mapping revealed hidden cosmic currents flowing across hundreds of millions of light years. The galaxy velocity maps showed streams of galaxies all flowing toward the same cosmic drainage basin. The Virgo supercluster wasn't an independent structure. It was part of a much larger river system of galaxies flowing through space together. This discovery completely redrew the cosmic map. Astronomers realized they had been looking at cosmic geography like ancient mapmakers who thought each island was separate. The velocity analysis revealed the hidden continental connections beneath the water. Your cosmic address suddenly expanded to include this newly discovered structure called Laniakea. You don't just live in the Virgo supercluster. You live in Laniakea, a massive supercluster of superclusters that contains everything within 500 million light-years of your location. Deep within Laniakea lies a gravitational monster that controls the motion of 100,000 galaxies. This cosmic beast devours everything that comes too close. The Great Attractor contains the mass equivalent to tens of thousands of galaxies packed into a relatively small space. Its gravitational pull reaches across Laniakea like invisible tentacles, dragging galaxy superclusters toward its location. Even the massive Virgo Supercluster cannot resist its pull. This gravitational powerhouse sits partially hidden behind our own galaxy. The Milky Way's dust clouds block direct observation of the Great Attractor. Scientists must use special wavelengths of light that can penetrate cosmic dust to study this invisible puppet master. The Great Attractor doesn't just influence nearby galaxies. Its gravity shapes the flow patterns across the entire Laniakea structure. Galaxy superclusters stream toward it like rivers flowing toward the ocean. Nothing within 500 million light-years can escape its gravitational influence. Your cosmic journey through space follows a path determined by this distant gravitational giant. Every galaxy in Laniakea, including our local group, rides cosmic currents that ultimately flow toward the Great Attractor's irresistible gravitational embrace. Where does Laniakea end and the rest of the universe begin? The answer lies in cosmic watersheds that you cannot see. Scientists map these boundaries by tracking which direction galaxies flow through space. Galaxies inside Laniakea all flow toward the same gravitational drainage basin. Galaxies outside Laniakea flow toward different attractors in other directions. The boundary between these cosmic watersheds marks where one supercluster ends and another begins. These invisible borders are as real as the continental divide that separates river systems on Earth. Water on one side flows to the Atlantic. Water on the other side flows to the Pacific. These gravitational watersheds remain stable for billions of years. The cosmic expansion of the universe cannot erase these natural boundary lines. They define permanent territories in the cosmic web based on which gravitational attractor controls each region. Your cosmic address includes this fundamental watershed geography. You live within Laniakea's gravitational basin, where all galaxy motion flows toward the Great Attractor, separated from neighboring superclusters by invisible cosmic divides that channel galactic traffic in different directions. How important is your location within Laniakea? The answer provides a humbling lesson in cosmic perspective. The local group sits near the outer edge of Laniakea, far from the action happening near the Great Attractor. We occupy a quiet suburb in this cosmic metropolis. The most dramatic gravitational interactions happen closer to Laniakea's dense central regions. Our peripheral location means we experience relatively weak gravitational forces from the Great Attractor. Closer superclusters get pulled toward this center much faster than we do. We ride the gentle outer currents of Laniakea's gravitational flow system. This outer position protects us from the cosmic chaos that dominates Laniakea's central regions. Galaxy superclusters near the Great Attractor experience violent gravitational interactions. Entire galaxy clusters get stripped apart by competing gravitational forces. Your address within Laniakea reflects this cosmic geography. You live in the local group, part of the Virgo Supercluster, positioned in the outer regions of Laniakea, riding the gentle gravitational currents far from the violent central maelstrom. Can cosmic structures grow infinitely large? The answer reveals a fundamental limit built into the fabric of the universe. Laniakea represents the largest gravitational structure that can exist in our cosmic epoch. Beyond 500 million light-years, the expansion of space itself becomes stronger than gravitational attraction. No larger structures can form because cosmic expansion tears them apart. This size limit means Laniakea-scale superclusters represent the universe's biggest neighborhoods. Larger structures would require gravitational forces strong enough to overcome universal expansion. Such forces don't exist in the current universe. The cosmic expansion acts like a cosmic speed limit for structure formation. Below this limit, gravity wins and structures stay bound together. Above this limit, expansion wins and structures get stretched apart faster than gravity can hold them together. Your cosmic address reaches its maximum possible scale with Laniakea. You cannot belong to anything larger because the universe's expansion prevents the formation of gravitational structures bigger than superclusters, making Laniakea the ultimate cosmic neighborhood that physics allows. What pattern emerges when you map the locations of millions of galaxies across billions of light years? The answer reveals the universe's most spectacular architecture. At the largest scales, galaxies don't scatter randomly through space. They organize into a vast network that looks remarkably like a spider's web. Thin threads of galaxies stretch across hundreds of millions of light years. Enormous empty bubbles sit between these cosmic threads. This structure is called the cosmic web. It represents the largest pattern of matter in the universe. Nothing bigger or more organized exists. The web contains every galaxy, every star, and every planet in the observable universe. The cosmic web's threads are called filaments. The empty spaces between them are called voids. Filaments contain most of the universe's visible matter. Voids contain almost nothing but empty space and a few scattered galaxies. Your cosmic address reaches its ultimate scale with this cosmic web. Laniakea and all other superclusters are simply bright nodes where multiple filaments intersect, creating the magnificent spiderweb pattern that defines the universe's largest scale structure. Dark matter built the cosmic web long before the first stars ever shone. This invisible material created the scaffolding that shaped everything we see today. In the early universe, dark matter was distributed almost evenly throughout space. Almost, but not quite. Tiny density variations of less than 1% existed in the primordial dark matter field. Over billions of years, these microscopic irregularities grew into the cosmic web's massive structure. Gravity amplified these small variations over cosmic time. Regions with slightly more dark matter attracted even more matter. Regions with slightly less dark matter became emptier. This process continued for 13.8 billion years until the tiny initial differences became enormous cosmic structures. Dark matter filaments formed first, creating invisible highways through space. Regular matter followed these dark matter roads, forming the galaxies we can actually see. The visible cosmic web is really just the tip of an iceberg built from dark matter. Your cosmic address depends entirely on this dark matter foundation. Every structure from your solar system to the cosmic web exists because dark matter's gravity organized the universe into the nested hierarchy that gives you a cosmic address. Most people imagine galaxies scattered evenly throughout space. The reality is far more extreme. Nearly all the universe's matter crowds into narrow cosmic highways. The cosmic web's filaments contain over 60% of all the matter in the universe. These thread-like structures are only a few million light-years wide, but stretch for hundreds of millions of light-years. They act like cosmic superhighways carrying galaxies between major intersection points. Between these matter-packed filaments lie vast cosmic voids. These empty regions can stretch for 300 million light-years without containing a single major galaxy. If you lived in a void, the night sky would be almost completely black. You might see only a handful of distant galaxies in the entire sky. This extreme concentration creates the most uneven distribution imaginable. The cosmic web divides the universe into crowded highways and empty wastelands with almost nothing in between. Matter clusters along one-dimensional threads, leaving three-dimensional volumes nearly empty. Your cosmic neighborhood sits along one of these cosmic superhighways. Every structure in your cosmic address, from the local group to Laniakea, follows the path laid out by cosmic web filaments that concentrate matter into the narrow threads of the universe's largest pattern. Where multiple cosmic web filaments meet, something extraordinary happens. These intersection points create the universe's most exclusive real estate. Laniakea sits at one of these cosmic crossroads. Several major filaments converge in our region of the universe, bringing together matter from multiple directions. This creates a cosmic traffic jam where superclusters accumulate at the intersection points. These nodes represent less than 1% of the universe's volume, but contain most of its visible matter. Galaxy superclusters only form where multiple filaments meet. Single filaments don't have enough matter to create structures as massive as Laniakea. The cosmic web's geometry means these intersection points are incredibly rare. Most of the universe consists of empty voids or single filaments carrying galaxies between intersections. Multi-filament nodes like the one containing Laniakea represent the universe's most special addresses. Your cosmic location couldn't be more privileged. You live at one of the universe's rare cosmic intersections, where multiple filaments of the cosmic web converge to create the concentrated matter density necessary for superclusters, galaxy clusters, galaxies, stars, and planets to exist. At what distance does the universe's clumpiness finally smooth out? The cosmic web provides the answer to this fundamental question. Beyond about 1 billion light-years, the cosmic web's pattern begins to fade. Individual filaments and voids become harder to distinguish. The universe starts to look more uniform as you sample larger and larger volumes of space. This smoothing scale marks the end of cosmic structure formation. Larger patterns cannot exist because they would require more time to form than the universe has existed. The cosmic web represents the largest structures that 13.8 billion years of cosmic evolution could create. Above this scale, the universe becomes statistically uniform. Every billion light-year cube of space contains roughly the same amount of matter. The dramatic variations we see at smaller scales average out when viewed from this cosmic perspective. Your complete cosmic address ends at this ultimate scale. Beyond the cosmic web, no larger structures exist to provide more levels of cosmic organization. The universe's address system reaches its natural limit, where space finally becomes uniform and featureless at the largest possible scales. Gravity doesn't work the same way at every cosmic scale. The smaller the structure, the tighter gravity's grip becomes. Your solar system is virtually indestructible. The sun's gravity holds Earth so tightly that nothing short of a stellar explosion could break us free. Planetary orbits remain stable for billions of years because gravity's strength increases dramatically at small distances. Galaxy clusters represent the opposite extreme. These massive structures barely hold together. The gravity binding thousands of galaxies is surprisingly weak compared to the forces trying to tear them apart. Many galaxy clusters will eventually dissolve as cosmic expansion stretches them beyond their gravitational breaking point. This scale-dependent strength explains why cosmic addresses have natural size limits. Small structures like solar systems and galaxies can maintain permanent addresses. Large structures like superclusters exist at the edge of gravitational stability. They form the boundary between permanent and temporary cosmic addresses. The physics of gravitational bonding creates a cosmic hierarchy where smaller structures always survive longer than larger ones. Your cosmic address becomes less permanent as you move up each level from solar system to cosmic web. Space itself fights against every gravitational bond in the universe. This invisible tug-of-war determines which cosmic structures can exist permanently. The universe has been expanding since the Big Bang, stretching space between all objects. This expansion acts like a cosmic wind trying to blow apart every gravitationally bound system. From your solar system to the largest superclusters, every cosmic structure must resist this universal stretching force. Gravity wins this battle at small scales but loses at large scales. The critical transition happens at about 300 million light-years. Structures smaller than this distance can overcome cosmic expansion through gravitational attraction. Structures larger than this get pulled apart by expanding space. This cosmic competition creates a sharp boundary in the universe's address system. Everything below the critical scale forms permanent gravitational neighborhoods. Everything above this scale gets stretched apart and destroyed by universal expansion. Your cosmic address exists only because gravity defeats expansion at every level from your solar system up to Laniakea. Beyond that scale, expansion wins the cosmic tug-of-war and prevents larger structures from forming stable addresses. A mysterious force is making cosmic expansion speed up. This acceleration is gradually erasing parts of your cosmic address. Scientists discovered that cosmic expansion isn't slowing down as expected. Instead, it's getting faster every billion years. This acceleration comes from dark energy, a mysterious force that fills empty space and pushes everything apart with increasing strength. Dark energy doesn't affect small structures like galaxies or galaxy clusters, but it does influence the largest cosmic structures. Superclusters that barely hold together today will be torn apart by accelerating expansion in the far future. This cosmic acceleration is slowly reducing the maximum size of stable gravitational structures. What we consider permanent cosmic addresses today may not remain bound together forever. The critical scale for gravitational stability is gradually shrinking as dark energy becomes stronger. Your cosmic address faces a long-term threat from this accelerating expansion. While your immediate neighborhood will remain stable for trillions of years, the largest structures in your cosmic address may eventually dissolve as dark energy wins the battle against gravity. Can gravity become dangerously strong? The answer reveals why cosmic structures have minimum safe distances built into their design. When objects get too close together, gravity stops being helpful and becomes destructive. The difference in gravitational pull between an object's near side and far side can literally tear it apart. This destructive limit is called the tidal boundary or Roche limit. Every gravitational system has these built-in safety zones. Moons that orbit too close to their planet get shredded into ring systems. Stars that approach black holes get stretched into long streams of hot gas. Even galaxies can be torn apart by tidal forces during close encounters. These tidal boundaries explain why cosmic addresses have minimum distances between neighboring objects. Planets must orbit far enough from their stars to avoid destruction. Stars must maintain safe distances from galaxy centers. Galaxies must keep proper spacing within clusters. Your cosmic address includes these safety margins at every level. From Earth's stable orbit around the Sun to our galaxy's safe distance from neighboring galaxies, gravitational physics builds protective boundaries into every level of cosmic structure. A simple mathematical relationship governs every stable structure in the universe. This cosmic equation determines whether your cosmic neighborhood can exist or not. The virial theorem states that stable gravitational systems must maintain a precise balance between motion energy and gravitational potential energy. Objects in the system must move fast enough to avoid collapse, but slow enough to avoid escape. This creates a cosmic Goldilocks zone for structural stability. Every level of your cosmic address obeys this mathematical law. Planets orbit at speeds that balance gravitational attraction with orbital motion. Stars and galaxies move at velocities that prevent the galaxy from either collapsing or flying apart. Galaxy clusters maintain the same delicate balance on larger scales. When this balance breaks down, cosmic structures either collapse into denser objects or expand and dissolve. The virial equilibrium acts like a cosmic thermostat, maintaining the conditions necessary for stable gravitational neighborhoods across all scales. Your entire cosmic address system depends on this mathematical principle. From the orbital mechanics of your solar system to the dynamics of superclusters, virial equilibrium provides the physical foundation that makes permanent cosmic addresses possible throughout the universe. Astronomers have detected something alarming about our galactic neighbor. Andromeda galaxy is speeding directly toward the Milky Way like a cosmic freight train. This galactic collision will happen in about 4.5 billion years. The two galaxies will merge into a single massive galaxy that scientists have nicknamed Milkomeda. This cosmic crash will completely rewrite every address in both galaxies. During the merger, gravitational chaos will scramble stellar neighborhoods. Our solar system will likely survive the collision because stars are separated by vast distances. But our galactic address will change completely as we become residents of an entirely different type of galaxy. The local group will cease to exist as a meaningful cosmic address. Instead of living in a galaxy group with multiple members, we'll inhabit a single giant elliptical galaxy. Our cosmic neighborhood will transform from a galactic suburb into a metropolitan core. Your cosmic address comes with an expiration date. The galactic collision will erase the current structure of local space, replacing your multi-galaxy neighborhood with a single massive galaxy that bears no resemblance to today's cosmic geography. What happens to cosmic addresses when the universe keeps expanding faster and faster? The answer reveals a lonely future for all cosmic structures. Dark energy is causing cosmic expansion to accelerate continuously. This invisible force pushes distant structures apart at ever-increasing speeds. Eventually, cosmic expansion will overcome even the strongest gravitational bonds holding large structures together. Superclusters like Laniakea will be the first casualties. These barely bound structures will dissolve as accelerating expansion stretches them beyond their gravitational breaking point. Your cosmic address will lose its largest scale components first. Galaxy clusters will survive longer but will eventually become isolated islands in expanding space. The Virgo cluster will no longer be part of a larger supercluster. Each cluster will drift alone through an increasingly empty universe. Your cosmic address will gradually shrink to smaller and smaller scales. What we consider vast cosmic neighborhoods today will become isolated cosmic islands, separated by distances so large that light from neighboring structures will never reach us again. Individual stars change over billions of years. When our sun evolves into a different type of star, it will destroy the cosmic address system we know today. Our sun will expand into a red giant star in about 5 billion years. This stellar evolution will vaporize the inner planets and fundamentally alter our solar system structure. Earth's address within the habitable zone will become meaningless when the habitable zone no longer exists. After the red giant phase, our sun will shrink into a white dwarf star. This stellar remnant will be much smaller and dimmer than today's sun. The surviving outer planets will orbit a completely different type of stellar system with new gravitational dynamics. Stellar evolution happens throughout the galaxy simultaneously. As massive stars explode and sun-like stars fade away, the galactic neighborhood will transform beyond recognition. Star formation will eventually cease as the galaxy runs out of gas to make new stars. Your solar system address faces inevitable transformation as stellar evolution reshapes every level of cosmic structure. The sun that defines your current stellar neighborhood will become a fundamentally different object, creating an alien cosmic address system. The Milky Way is not traveling through space randomly. We're being pulled toward a cosmic destination that will fundamentally change our galactic address. Gravity is slowly dragging our local group toward the massive Virgo cluster. This galactic metropolis contains thousands of galaxies packed into a relatively small cosmic volume. Our eventual arrival will transform us from suburban galaxy group residents into urban cluster citizens. The journey to the Virgo cluster will take tens of billions of years. When we finally arrive, our galaxy will experience the chaos of cluster membership. Close gravitational encounters with neighboring galaxies will strip away our satellite galaxies and disrupt our galactic structure. Living in a galaxy cluster means dealing with intense gravitational interactions between thousands of neighboring galaxies. Our cosmic environment will transform from the peaceful isolation of galaxy group membership to the crowded violence of cluster dynamics. Your cosmic address will upgrade from a quiet galactic suburb to a bustling cosmic metropolis. The local group's peaceful independence will end when we become just another member of the Virgo cluster's enormous galactic community. Current theories predict that matter itself may not be permanent. If protons decay, the universe's entire addressing system will eventually disappear. Proton decay would occur on timescales of 10 to the 34 years or longer. This unimaginably distant future lies trillions upon trillions of times further ahead than the current age of the universe. At these timescales, even atomic nuclei may spontaneously disintegrate. If protons decay, all matter-based structures will eventually dissolve. Stars, planets, galaxies, and even black holes will slowly evaporate as their constituent particles disappear. The cosmic web itself will fade away as dark matter particles potentially decay along with ordinary matter. This ultimate dissolution would erase every possible cosmic address. No solar systems, no galaxies, no clusters, no cosmic web. The universe would become a thin soup of elementary particles with no structure and no meaningful addresses. Your cosmic address system depends entirely on the stability of matter itself. If the fundamental particles that build everything eventually decay, the entire concept of cosmic addresses will become meaningless in a universe too diffuse and empty to maintain any organized structure.